Good morning, students of grade 8. Today we are going to continue our measurement lesson. Last time we discussed about measurement, quantity, types of quantity, and then unit and fundamental units and derived units. Yes, today we'll continue through measurement of mass. Okay, measurement of mass. What do you mean by mass? Everyone knows this. It is not a hard topic. Mass is defined as amount of matter, isn't it? Defined as amount of matter present in a body. Okay, mass is defined as the amount of matter present in body. And you know matter, what do you mean by matter? Anything that occupies space. Okay, they are called mass. Anything that occupies space are called mass. Okay, and anything that occupies space is called matter. And what amount of matter is contained in an object, that is called mass. Okay? And that matter in most fundamental term, matter usually means subatomic particles like electron, proton and neutron, which forms an atom, and atoms form molecules, molecules form a substance. So what amount of mass is present in a particular substance particularly dictates what amount of those proton, neutron and electrons are present in that substance. Now its SI unit of mass is, you all know this, it is kilogram. Kilogram is SI unit of mass. So in short, it is gram. And it's subunits. Let's go to subunits. Subunits means smaller units than kilogram. Okay, 1 kilogram contains 1000 gram, and 1 gram contains 1000 milligram. 1 kilogram contains 1000 gram, also written as 10 to the power 3 gram, or 1 gram contains 1000 milligrams or 10 to the power 3 milligram. Okay, that's why you can combine in 1 kilogram, there are 1000 gram, and in 1 gram there is 1000 milligram, means in 1000 gram there should be 1000 milligram. So in overall it should be 3, 4, 5, 6. 60. It is also written as 10 to the power 6 milligram. So you can see 1 kilogram is equals to 10 to the power 6 milligram. Memorize this data. 1 kilogram is equals to 10 to the power 3 gram. 1 gram equals to 10 to the power 3 milligram, and 1 kilogram equals to 10 to the power 6 milligram. Okay. Now this is subunits, and the higher units of mass, the units which are higher than kilogram, or we also called multiple of kilograms. Higher units are, the most common unit used in measurement are quintal. 1 quintal is equals to 100 kilogram, and 1 ton, or also called 1 metric ton, is equals to 1000 kilogram. Okay. Multiple of kilogram, 1 quintal equals to 100 kilogram, and 1 ton equals to 1000 kilogram. Now what devices are used to measure mass? Devices used to measure mass, quite common. Commonly we use physical balance and standard weights. Okay, here I have drawn an example of physical balance. In its physical balance, you keep unknown mass over here, whose mass you need to measure. Yes, and you keep standard mass over here, which are also called torque. Yes, in general language, torque or standard mass. Now a particular standard mass has fixed amount of matter. Suppose this is a standard of 1 kilogram. That means it contains 1 kilogram of matter. Now if you keep 1 kilogram of standard mass here and you keep unknown mass over here, and if they are balanced in this physical balance, then you can safely say that this substance, this standard matter, this standard weight and this substance has equal amount of mass. In that way mass is measured by simple comparison method. Okay, now next one is their measurement of weight. Okay, are you confused about this mass and weight? Because mass and weight are two different things. Okay, they are not same. When we say what is your weight, if I ask you what is your weight, you might say, sir, my weight is 40 kg or my weight is 45 kg. You might say that, but no, that is not your weight, that is your mass. Okay, you have 40, your body might have 40 kg of mass or 45 kg of mass, that is not your weight. But what does it mean? It means that your weight is similar to 45 kg standard weight or 45 kg mass. That's why in general term we might say that my weight is 45 kg, but in actual science that is not your weight, that is your mass. Okay, now what do you mean by mass? It is we have already discussed, mass is the amount of matter content in a body. Mass is the amount of matter content in a body, but weight is not the amount of matter. Okay, weight is not matter. Indeed, weight is the force. Mass is matter, but weight is force. So weight is defined as the amount of force by which the earth attracts an object. Okay, you know that this is earth. Okay, and whatever substance you put on the surface of earth, that substance is being attracted by earth toward its center, and that force is called gravity. And what amount of gravity does an earth apply to different object? That entirely depends on its mass. You will later on study that force is equals to mass into acceleration due to gravity. Now here you can say acceleration due to gravity is constant, but mass is variable term. So if an object has more mass, the earth will apply more force to attract that object, and that means less weight. If an object has more weight, if an object has less mass, then the earth will apply less amount of gravity force to attract that object, and that object will have less amount of weight. Okay, so mass and weight are totally different matters. Mass is matter, weight is force. Being matter, you can say mass is scalar quantity. It does not have any direction, it is scalar quantity. But weight, it has direction. Weight is always applied to the center of earth. That is why weight is vector quantity. And next difference is that since they are different terms, obviously their units will also be different. The SI unit of mass is kilogram, but SI unit of weight is, it is not kilogram, it is Newton. SI unit of weight is Newton. So from now on, if in our science class I ask you what is your weight, and you don't say my weight is 45 kg. What do you say? Your weight is nearly 450 Newton. Okay, so whatever is your mass, multiply that with 9.8, you'll get your weight. And mass is related, or mass is dependent on density and volume. That means, that is, mass is equals to D into V. Mass is equals to density into volume. Whereas weight, it is dependent on, you already know, we have already discussed, weight is dependent on What are they? Mass and acceleration due to gravity. That is, weight is equals to m into g. Okay, this one is the differences between mass and weight. Once again, see, mass is the amount of matter content in a body, but weight is the amount of force by which the earth attracts an object, or you can say amount of force of gravity. Okay, and being matter, mass is scalar quantity, and being force, weight is vector quantity. SI unit of mass is kilogram and SI unit of weight is Newton. Mass is dependent on density and volume, that means m equals to d into v, but weight is dependent on mass and acceleration due to gravity, that means W equals to m into g. Now to measure devices to measure weight. Remember, to measure mass we used physical balance or beam balance. Yes, or that is all. Okay, physical balance here in previous paper. Devices used to measure mass is physical balance, but device used to measure weight is spring balance. Okay, and most of the digital balances also measures weight, and that weight is converted to mass while displaying. Now this much is for mass and weight. Now let's go to next topic, number 3, measurement of length. I suggest you keep a paper and pen in front of you, pause whenever you need, and start taking note. Measurement of length let's start by defining what do you mean by length. Okay, length is defined as distance between any two points. Distance between any 2 points is called length. For example, say this is one point and this is another point. Now whatever is the distance between these 2 points, it is called length. Okay, or sometimes the path may be curved as well. Okay, in that case the distance traveled by an object moving from this point A to B, overall it is considered as length. Now what is SI unit of length? SI unit of length is meter, you all know this. Okay, now sub units of meter, smaller units of meter, it is 1 meter is equals to 100 centimeter, that is 10 to the power minus 2 centimeter. Okay, 10 to the power 2, and also 1 centimeter is equals to 10 millimeter, and it gives us that 1 meter is equals to, in 1 meter there is 100 centimeter, and each centimeter contains 10 millimeter, that means 100 into 10 millimeter, so it gives us 1000 millimeter, that is 10 to the power 3 millimeter. 1 meter is equals to 10 to the power 3 millimeter. Now let's go to multiple of meter. Multiple of meter are, let's go to kilometer first. 1 kilometer is equals to 1000 meter. Okay, that means 10 to the power 3 meter. Or 1 hectometer. 1 hectometer is equals to 100 meter. Hecto means 100 in multiple. Okay, centi means 100 in division, whereas hecto means 100 in multiple. And 1 decameter is equals to 10 meter. Well, these terms are not in very much common use, but kilometer is often used, okay, in our daily life. Like What is the distance between Kathmandu and Lalitpur? It is around 7 kilometer, we say. Okay. What is the distance between Kathmandu and Bhaktapur? It is around 13 to 15 kilometer, we say. Or what is the length of Nepal from east to west? That is around 800 and something kilometer. Okay, that's it. To measure longer distances, we usually use kilometer, but hectometer and decameter, they are not in common use, so don't bother with it anymore. And what devices do we use? Devices used to measure length. Commonly scales or ruler, okay, tape, etc. are used to measure length. Now let's go to next one, the last one, measurement of time. Number 4, measurement of time. And what is time? Time is the duration between any two event. Okay, duration between any two event is called time. Now, what event is considered as standard in measurement of time? There must be some event, okay, to consider as a standard point. For example, AD or Christian calendar. The Christian calendar starts from the birth of Jesus Christ, isn't it? The birth of Jesus Christ is considered as the reference point or starting point. That is considered as an event, and by considering that point as event, then the time goes on. AD 1, AD 2, AD 3, and so on. Similarly, BS or Bikram Sambat. Yes, what marks? What is considered as an event for measuring Bikram Sambat? Well, this is quite disputed topic. Okay, some say that it started from the day that King Vikramaditya started his ruling his kingdom. Okay, some say it is related to religion. There are several myths, but still there are at least some event for BS to start. Okay, so now let's not go to this. Now let's go to simpler thing. In general, scientifically speaking, these are not scientific matters. Yes, okay, these are not scientific matter, but scientifically speaking, zenith is considered as standard event. Okay, zenith is considered as standard event. Now, what is zenith? When a sun is exactly, suppose this is you standing on earth, when sun is exactly above your head, then that point on the sky is called zenith. Okay, so whenever you are standing on earth, okay, when the sun rises from east, okay, this is suppose this is you, okay, sun rises from here, from east sun rises and sun moves. As time passes, sun moves toward west, isn't it? And at some point sun lies exactly above your head, and then again it keeps on moving, and when it reaches the west, it sets down. Okay, so sun rises up in east and sets down in west, and that particular moment when the sun is exactly above your head, then that moment or that position of sky is known as zenith. Okay, so today the sun reaches to zenith, then next day once again sun reaches to zenith, isn't it? The sun reaches to zenith, it passes through here, it sets, and next day it rises up and again it reaches to zenith. So when the sun is at zenith, that is considered as an event. Okay, so between these two events or between two events of zenith, it is considered as one solar day. Okay, do you understand what zenith is? Okay, now zenith is defined as, you might have a little bit concept of it. Zenith is defined as the imaginary point on the sky, sorry, not on, in the sky, which lies exactly above our head. So zenith might be different for different person or different particular. For Kathmandu and for Chapa, zenith is different for Kathmandu and Chapa. Okay, and one more information: when the sun lies exactly at zenith, that time is regarded as 12 o'clock or 12 noon. Okay, when the sun lies exactly at zenith, that time is regarded as 12 o'clock. Okay, zenith is defined as the imaginary point in the sky which lies exactly above our head. Now, how is defined one solar weight? I already told, one solar day. I already told you that the duration between two consecutive events. You already know time is the duration between any two events. But in case of one solar day, what is considered as an event? Okay, what is considered as an event? It is the event of sun reaching the zenith. The consecutive event of the sun arriving to the zenith. What does it mean? Okay, is called one solar day. Remember this. What does it mean? Okay, sun reaches to zenith. This is considered as one event. Then the sun moves on. The sun sets down and through the night occurs, and next morning sun rises up, and again sun reaches to zenith. Okay, so the sun reaching to zenith is considered as an event. Okay, this is one event of sun reaching to zenith, and again sun reaches zenith. This is second event, and the time duration between these two events is considered as one solar day. And it has been calculated that one solar day is divided exactly into 86,400 parts. One solar day is divided exactly into 86,400 parts, which is also called second. Okay, that means in one solar day there are 86,400 second. That's why reverse it in 1 second. 1 second means one part out of 86,400 parts of an hour. Okay, sorry, not hour, sorry, day. One part of 86,400 parts of a day. Okay. If you divide one day into 86,400 parts, then one part is equivalent to 1 second. That's why you can use this as the definition. 1 second is defined as one part out of 86,400 parts of a day. Okay, now what devices are used to measure time? In ancient time they use sundial. In some cases they use sand glass. Sundial is somewhat like this. This is a circular disc and it has needle kept in like this. Okay, and then as the sun rotates, the shadow of needle also rotates, and the position of shadow is utilized to indicate or measure the time of the day. This is sundial. Okay, and another ancient measuring device is a sand glass, a glass which looks like two cups connected to each other. A glass which looks like two cups connected to each other with a narrow groove between them. Okay? And sand is filled in one of them. And this sand, when it moves slowly through this narrow groove, and the sand is collected over here. That means within certain time period, within fixed time period, sand in this upper glass, upper cup will become empty, and sand in lower cup will be filled. This is called sand glass, and different varieties of glasses were available. Some sand glasses measures 1 hour time. Most typical sand glass measures 1 hour time. However, there are sand glasses that measure 10-hour time or even 1 day time, okay, or some measures 15-minute time. There are different varieties of sand glasses available. But nowadays, neither we use sundial nor we use sand glass. We use watches. Okay, and there are different types of watches like mechanical watch, quartz watch, and atomic watch. Now let's say mechanical watch. Mechanical watch is also known as pendulum watch. Okay, like you have seen something like this. This is a clock, and then here something is hanging like this. Yes, and this is called pendulum or blob. It keeps on moving, or that movement is called oscillation. Okay, like this. It moves certain distance, comes back, and then another in another direction, keeps on moving. Okay, that movement is called oscillation, and this watch measures the rate of oscillation. Okay, by measuring the rate of oscillation, it gives us time. And another one is quartz watch. So most of the watches we use in our wrist, and nowadays most of the watches that we use as wall clock, they all use quartz crystal. They all use quartz crystal. Okay, and that quartz crystal, it vibrates. Okay, so these watches measure the vibration of quartz crystal to measure time. And atomic watches, these are highly sensitive watches which use cesium-133 isotope. Instead of quartz, they use cesium-132 isotope, and the radiation level, it measures the radiation level of cesium-133 isotope. This is radioactive element. It emits radiation, and what amount of radiation is being released by this isotope, that event is utilized to measure time. And among these three, this is the most accurate watch. That's why atomic watch is only used in delicate scientific experiments. We do not use it in our day-to-day life. Moreover, it is also used by Central Bureau of Weight and Measures, which keep time. Okay, and that time is considered as standard. Now let's go to our numerical section. Conversion of units. And you know, there are sub-units and multiple of units. Whenever you convert to sub-units, what you do? You need to multiply. Remember, whenever you convert to sub-units, you multiply. And whenever you convert to multiple units, you divide. See, these are quite opposite terms. Yes, you need to go to a smaller unit, you have to multiply, and you need to go to larger unit or multiple unit, you have to divide. For example, let's take an example: kilogram to gram or gram to kilogram. See, you are given kilogram, like 2.5 kilogram, and you need to convert it to gram. Gram is sub unit. Yes, so you need to multiply. We know while writing given information, given notation, always write that what information is given, that should be in left. 1 kg equals to what information you need, that should be on right. 1 kg equals to 1000 gram. Okay, so in the same case here, let's say you have to convert 7500 gram into kilogram, and kilogram is multiple unit. Yes, so you need to divide in this case, and in this case also given information is gram, so 1000 gram is equals to 1 kg. Yes, it will make the process easier. What is given, write it in left. what you need to find, write it in right side. Okay, now here, or you can use unitary method. 1 kg equals 1000 gram, then 2.5 kg is equals to multiply 2.5 into 1000 gram, and it gives you 2500 gram. This is your answer. And here use unitary method. 1 gram is equals to if 1000 gram equals 1 kg, then 1 gram equals to 1 upon 1000 kg, or 7500 grams should be equals to 7500 into 1 by 1000. That means 7500 is divided by 1000. See, convert to multiple unit, convert to sub unit, you have to multiply, yes, and convert to multiple unit, you have to divide. This to 0 0 cancel, it gives you 7.5 kilogram. Okay, or you can avoid this step as this step if you have confidence. Okay, you understand this or not, you need to practice this several times. Like whenever you need to convert to sub multiple units, then you have to multiply, and whenever you need to convert to multiple units, then you have to divide. Let's go to another example, like 3 meter into millimeter. Now see, or another example, 3700 millimeter into meter. Now you can tell me 3 meter into millimeter, this is conversion to sub unit, sub multiple unit, or multiple unit? Yes, this is conversion to sub multiple unit. Okay, this is conversion to sub multiple unit. And millimeter into meter, this is larger unit. Yes, that means this is multiple unit. Now what we know, in 1 meter how many millimeters are there? We know that. We know 1 meter is equals to, I'm starting from meter, yes, 1 meter equals to 100 centimeter, and 1 centimeter is equals to 10 millimeter. Therefore it gives us 1 meter equals to, multiply this to 100 into 10 equals 1000 millimeter. If 1 meter equals 1000 millimeter, then 3 meters should be 3 into 1000 millimeter, and gives us 3000 millimeter. Okay, and here we know we need to start from millimeter to meter, isn't it? That means we know that 10 millimeter is equals to 1 centimeter. We are starting from millimeter. 10 millimeter equals 1 centimeter, and 100 centimeter equals to 1 meter. Therefore it gives us, multiply this to term, 1000 millimeter, and multiply this to term, you get 1 meter. And left side we are taking unit of first term, okay, and on right side we are taking unit of last term. Here also same, first term and last term. Okay, so 1000 millimeter equals to 1 meter, or 1 millimeter is equals to, you all know, 1 by 1000 millimeter. It gives us like this, and then you need to find out 3700 millimeter, which should be equals to 3700 divided by 1000 millimeter, and it gives us 3.7 meter. 3.7 meter. This is your answer. Okay, so whenever you need to convert one unit to another unit, just see whether that that is conversion to sub multiple unit, or that is conversion to multiple unit. You just need to see that. If that is sub multiple unit, you need to multiply. If that is multiple unit, you need to divide. Memorize these two conditions. It will be very easy. And while writing given information, always start from what information is given here and end up to what information you need to find. Okay, use this trick. It will be easier for you to convert any given units. Okay, now do some questions for practice. Like 1 day, number A, 1 day into seconds. This is for practice. And number B, 2000 kilogram into gram. Number C, 25 hours into minute. And number D, 2505 kilometer into meter. Okay, and number E, 7250 meter into centimeter. Number F, 29,600 second into hour. Okay, do these 6 questions as practice, and this ends our lesson here. I will post the picture of exercise from book in our group in Messenger. Take it from there. This is your homework. You need to submit it by tomorrow through via personal message. Okay, that's for today. That's all for today. Thank you, class.